Welcome back to another video. Today we're going to be talking about related accelerations. If we go up to the key equations that we wrote out in the concepts video, just take a note that the highlighted terms are the position vector, not the velocity vectors. That was a mistake and it is now changed. So let's get into it. This problem asks us the bar rotates with a counterclockwise angular velocity of 20 radians per second and a counterclockwise angular acceleration of 6 radians per second squared. They want us to determine the acceleration of point A, and using the results from part A, determine the acceleration of point B. So if you look at the diagram, you can notice that point O, A, and B are all on the same rigid body. So we could relate any of them to each other, but if you look at point B, we don't know anything about point B, but we do know that point O is stationary. So that piece of information allows us to find the acceleration of point A because it gets rid of an unknown in our equation. So after we find the acceleration of point A, they want us to find the acceleration of point B with respect to point A. And that is possible because we just found the acceleration of point A. But we could relate point B to point O because we know information about point O. So it's up to you if they don't specify, but they are specifying that they want it with respect to point A. So let's write out our givens. The angular velocity of this bar is equal to 20 radians per second. The angular acceleration of this bar is equal to 6 radians per second squared. And they're both counterclockwise, so they're both positive. So they're asking us to find the acceleration of point A and the acceleration of point B. So referencing the key equations from above, we can use the related accelerations, and we can use the planar equation because this is a planar problem. It's 2D, so that's the equation we're using, but we can't just keep A and B the same because we're relating A to O. So we can rewrite this equation with O instead of B. So if we look at which terms we know the angular velocity, the position from O to A, and the angular acceleration. And we know that the acceleration of point O is 0. So we can plug in all of our values. And then you can tell that from O to A, it's just 1 meter in the positive j hat direction right there. And then subtract the angular velocity, which they gave us. And then multiply by that same position vector. Now we can simplify the equation a little bit. So taking the cross product, we'll get 6j hat, and then subtract 400i from that. Let's rewrite these components so that it's in the I hat plus j hat convention so that we don't confuse ourselves later. And that's going to be meters per second squared. Okay, so that's part A. Now we need to find the acceleration of point B with respect to the acceleration of point A, which we just found to be that. Now we need to relate point B to point A, so using that same equation as before, except instead of A we have B, and instead of O we have A, because we're relating point B to point A, so that's how you rewrite it. And then taking a look at which terms we know the position from A to B, the angular velocity, the angular acceleration, and we already found the acceleration of point A. So, plugging in our knowns, we'll put the acceleration of point A right there, and then add the angular acceleration, and cross it with the position vector from A to B. and then subtract the angular velocity squared, and then multiply that by the position vector from A to B, which is, again, 1 meter. Now we can simplify this equation by taking the cross product, and the cross product of 6k crossed with 1 I hat is going to be the same as above, which is 6j hat. So let's rewrite this, keeping the acceleration of A the same for now. And then adding 6j hat. And then 20 squared is 400, and it's going to be in the I hat direction. So now we can relate our components together. So that is the I hat component, and that's going to be the j hat component. So let's rewrite that. So those are the I hat components, and those are the j hat components. Now we're going to simplify those terms to be one term per component. So that's going to be the I hat component, and that's the j hat component. And that's in meters per second squared, and that's the acceleration of point B when you relate it to point A. So this acceleration of point B is always going to be the acceleration of point B. We just used the acceleration of point A to find it. So it's going to be the same regardless of which point on the rigid body you're relating it to. I hope this video helped. I'll see you next time.